All right, great engagement in the chat. Yeah, by the way, use the chat to ask questions. If you guys want to talk with one another about what John's going to show you today on turtle programming, I think that's totally fine. My name is Eric Archer. I'm your host for this webinar. Glad to be here, excited to be here, and we're going to talk through turtle today. I am not going to teach this webinar. My friend John Hanna is going to do it. But before we turn it over to John, I want to go over some housekeeping items with you. I already mentioned the chat, so please use that. Ask questions. If I can't answer your question in the chat, I can interrupt John and get an answer for you. There will be a survey after the session is over. You'll see that pop up. We'd love it if you could complete that survey. Kind of let us know what you thought went well, what maybe could be improved, and we'll take that feedback and try to make changes for the future webinars. And resources and recordings. So the materials that John's going to share with you in this session and the recording itself of this webinar will be available to you on the event website. So make sure you check that out. All right, John, are you ready to go here?
Good morning, Eric, or good afternoon, wherever you are in the world. Yes, I'm set to go. Pass it over to me.
Excellent. I just want to mention one more thing. So those of you that hang with us through the next hour will be eligible for some TI technology. We'll do a drawing at the end, and I'll announce the winner at the end of the webinar as well. And then that technology will be, someone from TI will reach out to you, get the information, shipping information from you, and then it will be shipped to you. And so that'll probably happen within a few days after the TCube conference is done today. All right, John, I'm going to turn it over to you. I'm going to stop sharing my screen here, and it's all yours.
Okay, thanks, Eric. I'm still John Hanna right now I'm in Hopatcong, New Jersey, largest lake in New Jersey, nearby. Been doing this for about 30 years with Texas Instruments. I'm a retired math and computer science teacher, and I'm responsible for all things TI codes. If you know the TI website and all the materials that are available through programming, that was all my work. So today's session is on turtle graphics and geometry. I'm going to stop my video for a moment so that you don't have to watch me just punching keys on the keyboard. Share my screen and share. And with luck, you should see both my TI-Nspire software and my TI Smart View software up on your screen right now. Thumbs up. Turtle graphics and geometry. About 3 years ago, a guy from Europe named Hans Martin Hilbig and I developed a turtle module for Python on the TI-Nspire, and TI took over the project and turned it into the turtle graphics module that we see today. This is for rank beginners, and back in February, a young gentleman from Alabama who was running a technology program in the University of South Alabama attended the T-Cubed conference in February in Fort Worth, got hooked on what he saw as a connection between the turtle graphics, the rover, and the Tello drone. So we have all three dimensions covered here. We have the turtle graphics on the computer, we have the rover on the floor, and we have a drone in the air. And I went to Alabama a couple of different times and did a workshop on all three devices in one day. So the turtle graphics starts out very simple and deep. The history. Before I get into actually doing the materials here, I have to show you why it's called turtle graphics in the first place. So I discovered this website. I was looking up history of turtle graphics, came across this website, and there's a link to this site in your materials for the resources. And what has struck me about this page was this picture. Why was it called turtle graphics? And before they started doing this stuff on a computer, with graphics on a computer, they built this machine that looks like a turtle, and the child is programming this turtle using that keypad on the side of this drawing. So the term turtle graphics came about because of its appearance, that it actually looks like a turtle in this image. So again, a link to this page is available in the resources section of the materials. The other interesting thing about this web page, though, is that it contains Python code that you can actually try out. So you can save and run this program here, and it actually executes on the page. That's pretty amazing that this Python material is all over the place. Why Python? It's a very friendly language. It's easy to learn, but it's very powerful and very deep because of the way that it's designed. I'm going to go back to my document now and talk a little bit more about turtle graphics on the TI-Nspire. Another document open up here is, come back here. This file is in the resources as well. It's one that I wrote for the workshops that I did on turtle graphics. And as part of the document, if I scroll down the page a little bit more, you'll find some sample code in here. But most importantly is that in this document are links to download the calculator files and the documentation from TI's website. So you can use Python turtle graphics in Python on the TI-Nspire, and you can use it on the TI-84 plus CE Python edition. The Python edition TI-84 is a special calculator with Python built into it. It's a new device. No, you cannot update your calculators to run Python. You have to buy a new TI-Nspire TI-84 plus CE Python edition calculator to get Python to work. The turtle modules on the Nspire are all in one file. It's just a simple open up a TNS file, and the instructions for installing it on your device are right on the first page of the screen. On the 84, you have to load both two different files, a turtle file and a grid file, that are app variables that get stored in your calculator permanently. And they will allow you to do Python with turtle graphics on the 84. You can read the rest of this stuff. There's some sample programs down here, and we'll actually get into doing this kind of coding in just a moment. But you can see the similarities between the two platforms on this screen shots in the middle of this page. This is the Nspire menus, and this is the 84 menus, and they're very, very similar. They're not identical, but they're very similar, as we'll see in a moment. So put that guy aside and get back to turtle graphics and geometry. So this first file, turtle activities, is the name of the file. And again, it's going to be stored in your resources for this workshop. The link to download these files that I have on here is a link to my Google Drive folder that has all these files in it as well. So if you like, you can take a screenshot of this page or take a picture with your smartphone, and you visit that site to get these files now. But you'd rather listen to me. So hold on a second. On the next page is our first step. Now, this file I used in a workshop where teachers had no programming experience and no TI-Nspire experience. So I passed out this file using the Nspire Navigator system, had them open up the file on the calculators, which is very easy to do. And then navigating through the pages is a piece of cake if you just hit Control right arrow or click on the tabs at the top of the page. If you're not familiar with TI-Nspire, it's very easy to use a TI-Nspire document. So step one is to make a square. On the following page, I provide the code for making a square. This is a Python program, all pre-made, but incomplete. Your job is to fill in the blanks. There are 3 sets of parentheses in this code, and your task is to create numbers in those 3 spaces that will make a square. To run a Python program on the TI-Nspire, you press Control R. So over on the left-hand side of my screen here, if I press the Control key and the letter R to run the program. We get an error message. Error messages are very common, and that's how you learn to program. When you see an error message appear on the screen, start at the bottom of the screen and work your way up. Don't start at the top of the screen because there's a lot of gobbledygook up here. The type error means function missing one required positional argument. What does that mean? Well, if I look up a little bit further, I see a line number explained in the code, line 4. So I need to go back to my program and find out what's on line 4 that needs an argument. To go back to the page, I can click on page 1.3 on the top of the screen, or I can hit the control left arrow key on my computer keyboard or handheld. Line 4 is this line because it says line 4 of 8 in the top right-hand corner of the screen. So this is what appears on line 4. And there's a number that's missing inside these parentheses. What number belongs there? I should watch the chat window. So I'll put a 4 in here.
Just got an answer there, John. 4 was the answer, so you hit the good timing.
And I press Control R to run it again. And now the program works fine. The program generates a graphics screen. It's got an X and a Y axis on it. It's got some grid lines on it in light blue. And it's got the turtle. The turtle is that yellow triangle with the blue border. The turtle starts out at the origin facing to the right. And you notice that the turtle moved a bit while the program was running. Now the program says finished at the top of the screen. So in order to erase the graphics screen, I can press any key and the graphics screen goes away. And what we're looking at here, remember the line error that I had before? This is known as the Python shell. Python programs are edited in a Python editor, and Python programs are executed in a special Python shell. These are 2 Python apps that have been added to the TI-Nspire platform. To get back to the Python program that was on page 1.3, I can click on the 1.3 and go back into the program. And the last 2 arguments in here, t.forward and t.left, are also missing arguments. So it did do some left turns in there. You saw the turtle change orientation 4 times. So it must have some default values that these functions accept. If I don't provide an argument for these functions, they don't crash like the range function did. They just happily do their own thing, and I have no idea what that thing is. So I'm going to give this thing a number, and this thing a number, and run the program again. Now I can see something beginning to happen, but it's not really making a square. So I press a key to close the graphics screen, go back to my code again, and tweak these numbers so that it actually does make a square. And it's pretty easy to figure out after a little hunting and pecking that some other numbers work better than others. So here's a square. Why did I choose 25? If I look at my screen, I see this 25 down in the lower left-hand corner, which tells me that that's the grid spacing. But 25 what? And the answer to that is 25 pixels between the origin and this first grid mark on the screen. So the turtle goes forward 25 pixels, turns left 90 degrees and goes forward 25 pixels, turns left 90 degrees and goes forward 25 pixels, and turns left 90 degrees again to complete the square. Press a key, go back to the code, and let me explain the rest of the code in here. First of all, Python is a very minimal program language. There's very little included in the basic code. It's called the built-ins, and there's not very much there. So anything that you want to do in a more advanced world like a Turtle graphics program means that you have to import a file so that it can use the functions in that file. So the first statement from Turtle import star means from the Turtle module, import everything. The star means everything. The second line in the code says T equals turtle. This is an object-oriented programming language in this state. T equals turtle creates a turtle object called T, which means that T has a lot of new functions available to it. The for loop is a built-in feature of Python. Most programming languages have built-in control structures. Python is no different, and the syntax is for some loop control variable in some range. This range function generates values up to 4. The actual values are 0, 1, 2, and 3, and it stops when it reaches 4. So the 4 values generated are 0, 1, 2, and 3. And that's not important for this activity, what actual numbers are being used. I just want to do something 4 times. The something that I want to do is indented 2 spaces. So these 2 little diamonds at the beginning of this line are simply spaces. But the TI developers provided this little light gray diamond in there to indicate how many spaces are in front of that statement. And other editors, Python editors, you have no clue as to how many spaces you're actually typing. TI gave us these 2 spaces to make it easier to line things up. Because Python requires indentation to define a block. So these 2 spaces are part of the for loop block of code, these 2 lines. At the end of the program, nothing happens. This is the end of the code. When I run the program again, it does things 4 times and goes back to its starting point. It went forward, turn left 4 times. Press a key, go back to the code. And I'm going to, for those of you interested in programming this on the TI-84, this is the Python edition. So to bring up this same code on the 84, I press the program key. On the 84 Python edition, instead of going directly into TI Basic, it gives a choice of to program in TI Basic or to program in Python. Select Python app. These are the files that are in my TI-84 Plus. These first 3 are included with the Python system. The 4th one here is the program that I was writing on the Nspire. I'm going to choose Edit down here. And you see the exact same code. I'm going to blow this up to make it easier to see. I know your screens are a little bit small. So we'll blow this up to a larger screen so you can see it for a moment. So the same code on the that you saw in the Nspire is actually written in the TI-84 Python editor. Let me fix something. I think I'm trying to do something else. So I need to provide the same numbers in here that I did before. If I put a 4 here, let's make it 50 this time instead of 25, and a left 90. And if I hit the run key, which is not over here on the screen, rather it's on the trace key, because the trace key is the hotkey for this run menu item that's on the screen. So if I hit the trace key, that will run the program. And we see the exact same code, but it disappeared right away. What happened to that graphic? So I'll go back to the editor by pressing the editor key. There's one more statement that's important on the 84, and I'm going to erase those two dots, press the math key, go into the turtle module, and select T.done. And this will keep the graphics on the screen for me. When I press the run key this time, then the graphics remain on the screen because the program is actually still running until I press the clear key and look at the editor again. So this T.done pauses the execution and waits me to press the clear key so that the program can return to the shell. When I'm writing programs on the 84, I prefer using just the calculator view because I get confused and I try to press the run button on the screen rather than the trace key that's underneath it. So when I'm coding on the 84, I always keep it in this mode so that I remember to press the hotkeys on the bottom, the function keys, rather than the keys that are shown on the screen. So I'm not going to go any further with the TI-84 version. Just be aware that everything I do on the Nspire today can also be done on the TI-84 Python edition calculator. It doesn't say Python on my calculator screen yet. They haven't updated it that far, but this is the Python edition operating system. Okay, put that aside. And I'll blow up this screen a little bit more to make it easier to see. So we have a complete program here. And my next step is to say, well, why does it have to be a square? What do I need to change in this code to make it some other polygon? So let's talk about pentagon for a moment. What needs to change in the pentagon? Where's my chat window?
Let's see, John, no one's put anything in there yet. Oh, here we go. Number of sides.
Okay. Oh, I see chat comments popping up on my screen. Thank you.
Gotcha. You got it.
All right. So we want to change this 4 to however many sides there are going to be in this polygon. If I make this a 5, then what else needs to change in this code? Make a pentagon. I'll wait. The angle. I heard the angle. So what's the proper angle to turn to make a pentagon? I'll wait for a number. Somebody wrote 172 or 60. I'll wait for the right answer. 108. Sounds interesting. 72 sounds interesting. Let's try 108 because that was an interesting number. And if I press Control R, I've got something there, but it doesn't quite look like a pentagon that I would recognize. Go back to the code, try 72. And run that. And we get the idea that we have to turn left the exterior angle of this polygon, number of degrees. So somebody else commented that we should use, instead of 72, use 360 divided by 5. And it's perfectly legal to put expressions in as arguments, just like we do on a calculator. The Python interpreter will evaluate that expression and use 72 as the value there. Which leads me to the other option here. Somebody said number of sides as the arguments. Instead of 5, we can place a number here equals 7 if I want to make a septagon. And in place of the 5s in this code, we can use n. So we can introduce the concept of a variable right in the code without much effort. So if I want to make a 7-sided polygon, I use the n for the range argument to do it 7 times. And 360 divided by n would be the proper exterior angle, because 360 is the sum of the exterior angles of a polygon. And when I divide that by the number of sides, I would get a regular septagon. Turtle graphics is all designed about geometry. In fact, there was a whole curriculum one time developed as turtle geometry, doing this sort of stuff with turtle graphics. Another advantage to using a turtle as our model is that we can play the part of the turtle by actually walking out this path on the floor of the classroom. Have a student stand up and move forward 5 spaces, turn left 90 degrees, forward 5 spaces, and actually walk out the path that a turtle would make on the floor through human interaction. Go back to the code. So here we've introduced n equals 7 of a variable into the code. And I'm going to leave it at this for now, but you can see where it can go from here. One thing we can do is have an input statement at the beginning of the program so that users can enter the number of sides. And instead of saying n equals 7, we could say n equals input the number of sides. Next step, go on to part B here. Next step is to make a flower out of that polygon that we made in the first step. And the code for making a flower is partially complete in here. Again, the first 2 lines at the top of the code are to create a turtle object, import the turtle module, and define a turtle object, t equals turtle. The def function in here defines a function called petal. We'll get back to that later. In the for loop, I have for I in range 5, make a petal and turn left, but there's some numbers missing in these functions. So in this section of the code, I'm going to put the number n for the number of sides that I want my petal to contain. And this is going to be my polygon code that I showed from the first step. So I'm going to go back to my first page, my first program, hit Control left, Control left, Control left. I'm going to take this code and copy it by pressing Control C. Go forward to my flower program. And in place of the word none here, none is a dummy placeholder in Python. We'll erase that word none and replace, paste in, Control V, all the code from the polygon. But we don't have the right indentation in here. Everything under the function definition is indented 2 spaces, and everything under the for loop must be indented 2 spaces as well. But the pasting didn't provide those 2 spaces for me. I have to indent them myself. So the indentation, again, is a big headache in Python. It's the way that Python recognizes blocks of code. Again, these 2 spaces down here will have no effect on the code because they are really just spaces in the first place. So what needs to be done down here? I'm going to make 5 petals, but what does the petal function need? It needs something for the argument n in the petal function up here. So this is the place where we provide an argument for how big each of the polygon petals are going to be. And again, we have a left turn to make here. How far should this turn left? I'll wait for somebody to answer. No answers? Let's try 90 like we did before. Because there's nothing wrong with trying something out. You're not going to break anything when you're writing a program. The computer isn't going to yell at you. And when I run the program here, that's one pedal, two pedals, three pedals. Do you notice that the turtle is slowing down? It's happening at my end too. There's four pedals. Oh, and it's making a fifth pedal over the first pedal. So it's making five pedals, but they're not uniformly spaced around the center. And it's finally done. One feature of the Python on the TI-Nspire is to have that turtle showing all the time. It consumes a lot of resources in the Nspire because it's got to repaint the whole screen just to redraw the turtle. So I'm going to press escape, go back to my code, and we'll do two things in here to make things work a little bit more smoothly. Where are these functions all found? If you press the menu key, this is the Python editor's menu. There's a section called built-ins. These are the functions that are built into standard Python. And under this submenu, you'll have a bunch of other submenus. The functions is where you'll find defined function. Under control, you'll find all the control structures, if statements, for loops, and while loops. Under operations, you'll find all the symbolic operators, the assignment statement, the test for equality, relational operators, and logical operators. Under lists are all the list operators and list functions. Under type, we have the functions that convert that data from one type to another. And under I/O, we find input and print statements. But where are the turtle functions? For turtle functions, we have to browse down to more modules because it's not built into the TI-Nspire world. It's an add-on. And you'll find more modules contains a lot of stuff at the top. These are part of the more modules that doesn't quite fit on the main menu. And then on my computer, I have a bunch of other modules down below. And if I look down this list, eventually we'll come to turtle graphics. So when you install the turtle module onto your Nspire and you run this Python editor, you'll find turtle graphics functions on the more modules menu underneath turtle graphics. The from turtle import star statement is right at the top of the list. The move functions include forward, backward, right, and left, and a few others. The draw statements are to draw certain objects, to draw a circle, to make a dot, to make a stamp, or to write text on the screen. Pen control lets me pick the pen color or pick the pen up and put the pen down if you want to do graphical drawing. Under settings, we can use either degrees or radians for controlling the turning angle of the turtle. We can set the speed. We can show the turtle and hide the turtle. And this is what I'm going to use right now. We can set that grid value. It can be anything from 10 to 100. The default is 25, like you saw on the graphic screen. We can hide that scale completely so it doesn't distract you from doing other stuff. Hide the grid completely, or refresh the entire screen. The function that I want to grab off of this menu is hide turtle. because showing the turtle slows the process down. And when I run the program this time, you don't see the turtle, but it's still doing the drawing. It's an invisible turtle. And the speed is consistent throughout the entire drawing. Again, because the turtle has to be redrawn, the entire screen has to be redrawn behind it. And it's finished. The other thing I want to change in here is the number of petals. So I'm going to introduce another variable in the main part of the program down here. I'll call it PETALS equals, let's say, 5. And then in here, we need to change the range value to petals. And we need to change the turning angle to what? If I want the petals to be evenly spaced around the center of the screen, we'll use, thank you, 360 divided by petals as the argument for the left turn. So I've got 1, 2, 3, 4, and 5 7-sided petals. So again, looking at coding, I'm looking at the coding standpoint. We can introduce variables to control the shapes and sizes of things. In my workshops, a lot of people were wondering about coloring the flower. So there are 2 color commands that are available in here. There's a pen color, which will control the color of the pen, which is by default is black. So if I go to my menu, select more modules, I'm going to press the up arrow key because I know Turtle Graphics is at the bottom of my list. For those of you who get a lot of more modules in here, you can add other kinds of modules to your system. But one day, my Turtle Graphics module disappeared from the list. I knew it was installed, but I couldn't see it on this menu. And this menu is limited to 20 items. And I ran over the limit, and my Turtle Graphics module disappeared from the menu. It was still in there, but I had too many things on this list for the Turtle Graphics menu to appear. So in here, we're going to go to pen control, select pen color. And in the latest version, it gives us a list of colors to choose from. And you can select a color from this list. For the time being, let's make it a blue flower. And if you don't like that choice of colors, you can make your own. I'm going to leave that with the way it is, but also state that you could also use the arguments red, green, and blue values. So if I do 128, 128, 0, I can use the R, G, and B values in this pen color, and this would produce the color yellow on the screen. I'm assuming, I haven't seen it yet because I haven't tried it, that blue would be 0, 0, 255. So using the word blue would produce the same color as 0, 0, 255 for the R, G, and B values of this system. When I run the program now, I should get a blue flower, but it's only outlined in blue. I'm going to break the program by pressing the break key. On the Nspire, you would press and hold the on key down to break the program. On my computer, I have to hit the F12 key to break the program and go back to the code. Oh, let's talk about full colors. Press menu, more modules, Turtle Graphics, And filling has got its own special menu because there are 3 different functions that are required. There's setting the fill color, and then you have to tell it to begin filling and end filling to complete the fill of a polygon. So the fill color we'll choose first, and we can set that up at the beginning of the program. I chose the wrong one, didn't I? Delete that one. And choose it again, menu, more modules, turtle graphics, filling, and fill color. And we'll choose red. When we draw each polygon, and that's done up here in the petal function, this is the polygon drawing process. At the beginning of this drawing, we institute the begin fill function, and at the end of the loop, we institute the end fill function. So I'll choose menu, more modules, turtle graphics, filling, begin fill. The extra lines in here don't mean anything to the program, but we're going to erase them so that it fits all on one screen. And then at the end of the for loop, indent 2 spaces to become part of the petal function and institute the end fill command. Instead of selecting it from the menu, I can just type it in by hand, as long as I know how to spell it. So any function that you can find on the menus, you can type in by hand, but it has to be spelled and indented exactly correctly. So this loop will now begin filling and end filling, so it should fill each polygon in red, perhaps. So we get a blue border and then a red polygon. Blue border, red polygon, all the way around 5 times. So you notice that some of the boundaries are hidden from view, and it would be a challenge to the students to create a program that would generate both the red petals and all of the blue segments on the screen at the same time. But that will leave that up as a challenge. So color comes into a big play when you're writing Python turtle programs, because turtle graphics can be very colorful. To program with turtle from scratch, I'll go to the next page. I'm going to follow the instructions on this screen. I'll press Control-I. Control-I or Control-Doc adds a page to the document. And I have to select Add Python from the bottom of the list. Select New for a new program and give the program a name. Let's call it star. I'm going to make a 5-pointed star. The type of program is going to be a blank program, but when you get into more advanced programming with Python, there are a bunch of templates to choose from on this list, including hub projects and rover coding. But Turtle Graphics is not one of these modules, one of these templates. Geometry Graphics is using the TI Draw module. And in fact, the Turtle Graphics module uses all of those graphics commands to perform its work. But we're going to leave it as blank program. Hit the OK button. And I got a blank screen. This is the blank Python editor. We need to import the turtle module, so I'll press Menu, More Modules, Turtle Graphics, and select From Turtle Import Star. But in addition to the import statement, we also get the turtle object. So from here, it's a piece of cake to create a program using T as the turtle object. For I in range 5. I want to make a 5-pointed star. I go T dot forward 50 units and T dot left how much to make a 5-pointed star. I'll wait for an answer. Time's up. When I run this program now, the 5-pointed star appears. How did that happen? It took 2 turns, 2 revolutions to complete the 5-pointed star. Instead of 360 divided by 5 here, I use 720 divided by 5 as my turning angle. Because when I run this program again, keep an eye on the turtle, and you'll see that it rotates twice to make this star. There's an activity available on TI's website called Fireworks, and it was featured for the 4th of July stuff. And it's all about making star polygons. What's a good star to make? If you have a 7-pointed star, how far should each turn be to make a nice 7-pointed star? But we'll stop with that one right there because I'm running short on time. Here's a demo. And again, this is all part of the file that you'll receive if you download this from the resources section or my Google Drive folder. 4 turtles are at the corners of a square room, each facing the turtle to her right. They each move at the same time, each turning continuously to face her neighbor. How far does each walk until they meet? The next page is the completed code, and we won't go into what the code looks like here, but press Control R to see how the program runs. So each turtle is its own color. The reason I put this in here as a demo is that you can have more than one turtle on the screen at any time, and each one is controlled separately. The total distance they traveled is 200, and that's the size of the original side of the square. But here's the code, and you'll be able to investigate this code a little bit further if you download and open the file. P1 is one of the turtles. Its position is at negative PP. That's the one that's in the upper left-hand corner of that square. Its color is set to red. I hide the turtle and hide the grid. This turtle's heading is set to 0, which is 0 degrees to the right, and its speed is set to 10 to make it move as fast as possible. P2 is the second turtle at the point PP, which is in the top right-hand corner of the screen. And again, we said all the same things about the second turtle. The third turtle is at P negative P, down there in the fourth quadrant. And the fourth turtle, fourth quadrant. And the fourth turtle is at negative P, down there in the third quadrant. Turtle number 4 has the job of turning the screen black. So its pen color is set to black, 000 is black, and it makes a big dot. 332 pixels is bigger than the screen can fit, so the screen turns black. Then it changes the turtle back to its proper color and sets up a turtle list. These are the 4 turtles stored in a list, and then the for loop can process each turtle in the list for T in turts, and each turtle gets processed one at a time. Again, we won't go into the rest of the code. Just be aware that the magic in the code is right here, where each turtle's heading is set to go towards the turtle next to it. The towards function makes a turtle turn towards another turtle or another point on the screen. Again, running the program. So the white squares are there just for embellishment to make it look kind of three-dimensional. They're not really necessary to the object, to the goal of the program, which is to figure out how far each turtle turns. Another demo, if we're into computer graphics and fractals, Turtles graphics are amazing for doing some special turtle graphics. So this program, notice the name of the program up here, CX, CE, and DT. CX means it'll run on a TI-Nspire. CE means the same code will run on a TI-84 plus CE Python. And DT means it'll also run on the desktop. So I can copy and paste this code into any of these three platforms, and without any changes, it'll operate and do the same thing that it does here. Now, it takes a while at the beginning to figure out what device it's running on and what devices are available. Because in addition to doing it on any of those three platforms, it also has sound built in if there's a TI Innovator attached. So the red object is the Koch snowflake. The green object is the Koch anti-snowflake. It's the inverse of the Koch snowflake. So it draws through 5 iterations of the Koch snowflake. And again, you can examine the code for making the Koch snowflake. And it sees if it's running on a CX or CE, or if it's running on the desktop. If there's an innovator present, it will make sounds. And the real meat of the code is the Koch function in here itself. If stage and length are 2 arguments, and it's a recursive function, so it actually calls itself inside the function to draw the 4 different sections of each step of the way. Make a crystal is an interesting challenge. This code isn't provided in here, but can you duplicate this object using Turtle Graphics? And you saw how we made a flower before. This is very similar to the flower, but you have to figure out what shape and how many times the shape is being drawn to generate this shape. So here's your empty code, and your task is to create that crystal. Another document that's available, random walks. I was curious about how well the random number generator was doing. So a random walk means that the turtle will go either right or left if it's a one-dimensional walk. And if I run this program, here's the turtle moving right or left at random. I think it goes forward or backward 10 units at a time, each step of the way. Notice how the turtle is slowing down because it's got to redraw all those segments each time the turtle moves to a different position. So that's not very interesting. Hit escape and go back to the code. This is a very powerful tool right here. While get key does not equal escape. That's my favorite function in the world because it means just press the escape key to end the program. The direction is a choice between -10 and 10. This is a Python feature where choice is a function that takes a list as an argument. So you can choose to go either -10 or 10, and it selects a choice from this list, and it goes forward that direction. That's the whole program. But that wasn't enough for me. So here's a one-dimensional random walk with analysis. And when I run this program, it gives me a lot of data on the screen about where the turtle is going at each moment. By hiding the turtle, I have the program running much faster. So it's taken 350 steps so far. Half of the time it shows +10 and half of the time it shows -10. So I'm pretty happy with this plus percentage in here. The direction sums, if it's choosing -10 and 10 at random, shouldn't the direction sums be 0? Because half of the time it's choosing +10 and Half of the time it's choosing -10. And its average position now is 290. 300. That's way off to the right. Why isn't it average position 0? How come it didn't move to the left at all in here? And that kind of disturbs me about random number generators, that it seems like when it's running in, it goes off in one direction and kind of stays there. So here's a two-dimensional random walk, and it chooses to go up, down, left, or right at each time. And again, there's another one with analysis. But here are some of the screenshots of random walks. And they don't look like they focus around the origin at all. They seem to wander off in one direction or another at random. Ben and Elaine are two turtles that are chasing each other. Ben is chasing Elaine. Elaine's a little faster than Ben. I have to run out of time here, but Elaine wanders around the screen and Ben is always going towards Elaine. But if Elaine goes off the screen, then she comes back on the screen at some random position, and Ben has to turn to continue chasing her. So I don't know how long this is going to take, but there's a surprise ending. There we go.
Love it.
And fade to black. With that, I'm going to pause and pass the baton back to Eric, because I use up way too much time here.
Not at all.
Stop sharing my screen.
John, that was great.
And turn on my video. And I'm still standing here with strawberry shortcakes on the shelf.
John, great job. I always enjoy your webinars. I always learn so much. And the flower and the star, the adding color, and the random generator, it's just fantastic. So thank you so much for that. And if anybody has questions about Turtle, I think John put his email address in the first slide, and we can make sure that I think that it's available to you in the materials that you can download at the end of the conference.
Yep.
From the
It's in that file.
What's that, John?
It's in that file on the first page.
File. Yep, it's at the first slide on that file. You'll see it. Mm-hmm. And so now just I get the fun part here. I get to announce the winner. And today's winner is Tucker Green. And so Tucker, congratulations. You'll receive a TI graphing calculator, and that will be shipped to you. So the event organizers are going to reach out to you, get your contact information, and get that shipped to you. So I'm glad you won the calculator, and congratulations. With that, I think that's it for me. He just won earlier too. Oh my goodness, Tucker should play the lottery. So yeah, that's too funny. But well, I guess that's just the way it goes. So congratulations, Tucker. Looks like you're getting two calculators. So with that, I'll say goodbye, John. I'm going to put us into the practice session. Everybody else, the next session is going to start in 30 minutes at 1 o'clock. So you got 5 sessions to choose from. There's AP Pre-Calc, AP Calc, high stakes exams, data collection, and Algebra 1. So you got a lot of options to choose from, everybody. All right, thanks for being here.